So, do you see the screen? Yes or no? Slide. Not yet? Okay. I think there are some configurations from this Microsoft Teams and we are having problem है पहिलाको सजिलो गर्दै हुन्थ्यो अहिले झन् कम्प्लेक्स गर्दै गइरहेछ तिनीहरूले त्यही भएर इश्युजहरू आइरहेछ टिम्सको पनि. Okay, today we'll start with new slide, okay? And then it's IPv6 addressing. We did about IPv4 addressing, and now let's move on to IPv6 addressing. And here we'll be discussing about what were the IPv4 issues, and then IPv6 address representation, and IPv6 address types, then GUA, Global Unicast Address, and yes, Salasu, it's free. Ora. Okay, let me check. Is the issues are there in is like you teams ma I can't understand what's with this team. Okay, wait. I think there are two. Um, yeah, I'll share my screen. So now, do you see? Do you see the slide? Yes. Okay. So we'll be discussing about IPv6 issues, IPv6 types. Then we have this GUA and LLA, static configuration. Actually, we have already done this. हामीले यो गरिसकेको हो तर पढ्दा ढिलो पढेको practical IPv6 को configuration हामीले अगाडि नै गरिसकेका छौं. Then we have dynamic addressing for IPv6 means global unicast addresses. Then also we do for getting for IPv6 LLAs in locus. Then we'll discuss about what is IPv6 multicast address and then network. So IPv6 issues, okay? IPv4 issues, okay? IPv4 is running out of addresses. IPv6 is the successor of IPv4. IPv6 has a much larger 128 bits address space. The development of IPv6 also included fixes for IPv4 limitations and other enhancements. With an increasing internet population, IPv4 address space issues with NAT and IoT, okay, Internet of Things, the time has come to begin the transition to IPv6. Just the IPv4 address has got a capability of 4.3 billion addresses, right? 4.3 billion addresses Bhakoma, you can see in the graph, if you can see it clearly in the figure, if you can see clearly, just say North America already July 2015 the addresses has depleted, means no more new address available, free address available in North America. And if you look into Europe, September 2012, the so before that, and then in Asia Pacific, uh, you have June 2014, and Africa, it's estimated IPv4 exhaustion in 2020, okay, this year. And then in South America, April 2011. So only in Africa some addresses are available. Otherwise, the IPv4 has deleted. होइन अब नयाँ एड्रेस चाहिँ available छैन. So you have to use the old addresses. अहिलेको केसमा के छ भन्दा ठुलो ठुलो टेक कम्पनीहरू जस्तै फेसबुक and Google and even all organization they use IPv6 होइन त्यसरी slowly transition phase मा छ but the reason actually they already they want to implement this earlier and sooner as possible IPv6 उनीहरू चाहिँ जति सक्दो छिटो इम्प्लिमेन्ट गर्ने हतारमा त थिए but what happened the world was still using IPv4 and most of the part of the world still use IPv4 हैन अनि एउटा कुरा जस्तै we have public addresses हैन public address ले गर्दाखेरि and we have got this net and a public address a private address no sorry private address not public address we have got these private addresses 168 भयो अनि त्यसपछि 10 series को भयो त्यसपछि 172 series को प्राइभेट एड्रेसेस भयो अनि त्यसपछि नेटको कारणले गर्दाखेरि द युज अफ IPv6 बिकेम प्राइभेट एड्रेसेस हुँदैन थियो र नेटको प्रोभिजन हुँदैन थियो भने आई थिङ्क बाई दिस टाइम विड अलरेडी बी युजिङ IPv6 है बट even then के छ भन्दा जस्तै with the use of with the growing use of technology हैन internet and technology को use बढ्दै गएको हुनाले I think it's the race of only using IPv6 is coming closer and closer and maybe by 2030 or by 2035 or latest by 2040 we might all be using IPv6 okay but there is no particular date यही डेटमा चाहिँ IPv6 सुरु हुने भन्ने डेट चाहिँ छैन but maybe like devices अब तपाईहरुको नयाँ डिभाइसहरु आयो भने they will come with IPv6 हैन हुँदा त अब MAC address बाट you will know that with the help of MAC address the device can be configured into IPv6 हैन तर most of the devices will likely come with IPv6 so sooner than soon okay or sooner than sooner we'll be using IPv6 so IPv4 and IPv6 coexistence both IPv4 and IPv6 will coexist in the near future and the transition will take several years so you cannot just give up IPv4 okay it has been used and it will be in use for a certain amount of years but there is no particular date the IETF has created various protocols and tools to help network administrator migrate their network to IPv6. These migration techniques can be divided into three categories. Dual stack, the device that runs both IPv4 and IPv6 protocol stacks simultaneously. Tunneling, a method of transporting an IPv6 packet over an IPv4 network. The IPv6 packet is encapsulated inside the IPv4 packet. And then transition. Network address translator translation 64 NAT64 allows IPv6 enabled device to communicate with IPv4 enabled device using a translation technique similar to NAT4 IPv4 so here there are three different methods dual stack भनेको तपाईको एउटा राउटर छ that has got provision for to run both IPv4 and IPv4 हैन तर all structure चाहिँ IPv4 छ तर प्याकेट चाहिँ IPv6 पठाउनु पर्यो भने that IPv6 packet is encapsulated within IPv4 packet okay त्यो प्याकेटलाई चाहिँ IPv4 प्याकेट encapsulate गरेर through the IPv4 network चाहिँ यसलाई के गरिन्छ सेन्ड गरिन्छ that's known as tunneling and translation is using NAT64 यो स्पेसिफिक डिभाइस हो जस्तै त्यो फिचर NAT64 फिचर भएको राउटर if you use that router okay then IPv6 इनेबल डिभाइस सँग के गर्न सक्छ त्यसले कम्युनिकेट गर्न सक्छ जस्तै IPv4 को पनि so this device if it has got a NAT64, then it will use IPv6. Okay, and then it can translate. It can communicate with IPv6. Okay, so these are three mechanisms of using IPv6 or making the closer move to IPv6. Node tunneling and transition are for transitioning to native IPv6 and should only be used where needed. The goal should be native IPv6 communication from source to destination. Your tunneling र translation भनेको चाहिँ that's just for त्यो एउटा transition गर्नको लागि use, but that doesn't mean it's fully meant. त्यसले के गर्ने भयो, transition काम गर्ने भयो, तर implementation को काम we should trying to use to implement IPv6 in the system. Okay, and IPv6 representation. Okay, in this IPv6 representation, we have done a little bit in our lab as well, packet tracer. IPv6 addresses are 128 bits in length and written in hexadecimal. Just say IPv4 addresses are 32 bits, okay, in length and written in binary or decimal. But IPv6 address are 4 times greater in length, 32 for the 128, and written in hexadecimal of binary or IPv6 addresses are not case sensitive and can be written in either lower cases or uppercase. So it doesn't matter, हैन, तपाईले capital caps लेख्नु कि तपाईले small मा लेख्नु, it doesn't matter. The format for writing an IPv6 address is x colon x colon x colon x colon, and colon between them. Okay, so x represents decimal. Okay, so instead of using a dotted decimal colon, okay, in IPv6, is official to refer to the segment of 16 bits for hexadecimal values. So each of them is constructed. उसमा चाहिँ हामीले octet भन्छौँ हैन, 8 bits लाई. Okay, and in IPv6 we call it as hextet. So this IP, okay, I cannot select this one. It doesn't take. You can see 2001 colon then colons 1111. So this can be converted. We have done so. Let me see. It's not very difficult to convert hexadecimal to so one would be two, okay, and then 000 and 0001. So you can see each of the hex 6 bits. You can count here. And you can convert each of them into binary.
Excuse me, sir.
You have total. If you convert them, you have 128. Okay. Yeah. Yes.
सर हजुरको भोइस पनि आएन,
स्क्रिन सेयर भएको छैन सर.
त्यसले There's wait again. So do you listen now? Presentation पनि गइरहेको छ. Okay, let me. Yeah, last 1 week it has been terrible with the network. Okay, I've been complaining, and I've listed in the support at WorldLink yesterday, but it's becoming too late. Screen आयो अहिले? Do you see the screen? एकैछिनमा जान्छ. Let me, okay, okay. In case if that happens, please let me know. Okay. Um, okay, I'll again. Okay, I'll again revise what I did. Okay. And okay, here. Do you see this IPv6 address told? IPv6 addresses are 128 bits in length and written in hexadecimal. IPv4 we have 30 length or byte, and it's extensive and can be written in either lower cases or uppercase. In this case, you can. It doesn't matter if you write them in caps or small letters. And preferred format of writing an IPv6 address is x colon x colon x colon x. Okay, with each x consisting of 4 hexadecimal values. So each x, okay, you can see uh, the first example, 2001. If you convert 2001, okay, this is in hexadecimal. If you convert that into binary, 2 means 0010, okay, and then 0 means 4 zeros, and then again 0 means 4 zeros, and 1 means 001. So when you convert that into binary, you have 16 bits. Okay, that is how you can convert each of them into 16 bits. In IPv6, hexadecimal is the unofficial term used to refer to the segment of 16 bits or 4 hexadecimal values. So these 4 hexadecimal values are known as hex. In case of IPv4, the 8 were known as octets, and here these 4 digits hexadecimal values are known as hexstate. Example of IPv4 addresses in the preferred format. You can see 2001, okay, colon 0db8 colon 0000 colon 1111 colon 0000 colon 0000 colon 0000 and colon 0200. So this is IPv6 address, and there's another example as well. So IPv6 address representation. Okay. So do you see the slide? Omitting leading zeros. New slide. Vijay. No. This, I think Teams, when they update it, it's terrible. Screen affair. So I think this is also problem with the Teams. Vijay, do you see it now? Ah, okay. Uh, okay. Let me know if I change the slide. Okay, then lately पहिला त थिएन अहिले लेटली चाहिँ एकदम धेरै इस्यु आउनु लाग्छ है and also you can in case if you have your own slide you can also open up the slide. Okay, if you can just hear me you can also open your own slide, but sometime if I do any activities then you might not see that. Okay, let's see. IPv6 address representation. Rule 1, omitting leading zeros. So the first rule is to have reduced the notation of IPv6 addresses is to omit any leading zeros. Okay, so here you can see 01AB can be represented as 1AB. अगाडिको zeros leading zeros भनेको अगाडिको. Okay, you cannot remove the preceding zeros. Okay, so you have to omit the leading zeros. जुन अगाडिको जेरो छ त्यसलाई चाहिँ हामीले के गर्न सक्छौँ हटाउन सक्छौँ. You can see other one F0 can be represented as 9F0. 0A00 can be represented as A00 and 00A can be represented as A. All the one to leading zeros, not to trailing zeros. Trailing zeros, you can remove them. Otherwise, the address would be ambiguous. Ambiguous भनेको जस्तै कुन हो भनेर छुटाउन नसक्ने अगाडिको जो पनि हटाउने पछिको जेरो पनि हटाउने हटाएर राख्यो कतिवटा त्यसलाई के छ त गाह्रो हुन्छ के गरेर only the rule is omit leading zeros, not trailing zeros or preceding zeros. Okay, and type preferred is 2001 db8 colon 0000111 colon 000 and other zeros, four zeros, then 0200, then all of can be all leading zeros can be omitted. अगाडिका जिरोहरू यदि number of zeros at the front end can be removed. Okay, double colon. So did this slide change? Double colon, are you seeing double colon? Vijay?
Change भयो sir.
Double colon change भएको नि आएन. Okay, the network has been terrible. Okay, the rule 2 is a double colon. Okay, and this in double colon you can represent any single contiguous strings of one or more than 16 bits hex states consisting of zeros छ भने एउटा पनि हटाउन सकिन्छ अथवा contiguous zeros, then we can remove one, not two. यसमा example हेर्न सक्नुहुन्छ. Like you can omit those zeros and then you can shorten it putting like two double a single double colon. Okay, जस्तै माथिको केसमा तपाईले के गर्न सक्नुहुन्छ भन्दाखेरि two options. You can do 2 colon 0 db8. Okay, double colon 11, then you put same. त्यो राख्दा पनि हुन्छ नहुँदा हैन, you are not wrong. But if you want to read db8, okay, then you put 10 because you have to put 10 there, and then you do ones, all ones, and then double colon त्यो तीनटा जुन zeros छ that's hexed with all zeros, you can remove the double colon. Okay, and then you can shorten that one. Okay, like we also let's do one example. Let's do 210 db8. Okay, then you do 0000 colon 0000. Okay, and yes, answer. You can. Then we have this colon. Okay, and then we have 16 ed. Okay, and then you have 0000. Okay, and then colon 00123456 and colon 0340. Okay, we have one example. 2001B8 0000 and 16BD 0000 and 0000 and 0340. So how can we shorten this one? Oh, यसलाई हामीले compressed form मा कसरी लेख्न सकिन्छ? And yeah, first rule is omit rule 1. Rule 1 is omit leading zeros. Rule 1 के हो त omit leading zeros. Omit leading zeros गर्दाखेरि के आउँछ त? 2001. Okay, अनि db8. Okay, then we have 0. Again we have 0. And we have 16 ed. Okay, then we have 0. Then we have again 0. Then we have 340. Okay, this is rule 1, omit leading zeros. So first we compress it as this, and second, then we replace. Okay, rule 2 is replace one contiguous it's I think CONTI. Okay, contiguous zeros rule double colon. So rule 2 is there are a contiguous zeros चाहिँ हामीले के गर्नु पर्यो? We have to replace it with only one. You can here you can see there are two contiguous zeros. यहाँ पनि छ, यहाँ पनि छ. Okay, so you cannot remove both of them. Okay, you can only do one. The answer would be this one. Okay, when you remove contiguous zeros, then 2001, then db8, then you have two colons. Okay, and 16 db, and then you have 0 colon 0 and colon 340. this one or, okay, you can also do 2001 then colon db8. Okay, I think it's cap db8, and then you have 0, and then you have again 0. Okay, and then 16 db, and then you have double colon or 34, either of them. Okay, either you write the top one or you write the bottom one, it doesn't matter, both of them are correct. But only the rule is you can only replace one contiguous zero, one row or one zero contiguous zero चाहिँ दुई ठाउँमा छ भने पनि you can only replace one. Okay, did you understand this one? Tirtha, Vijay? दुईटा कन्टिन्युस एकातिरको मात्रै गर्न मिल्छ. ओके, दुईतिरको गर्न मिल्दैन, एकातिरको मात्रै गर्न. ओके, but any of them will be correct. Okay, IPv6 address type. Broad categories of IPv6 addresses. One of them is unicast, uniquely identifies an interface on an IPv6-enabled device. Multicast is used to send a single packet to multiple destinations. And anycast, this is any IPv6 unicast address that can be assigned to multiple devices. A packet sent to an anycast address is routed to the nearest device having that address. And unlike IPv4, IPv6 does not have a broadcast address. However, there is an IPv6 all node multicast addresses that essentially give the same result. यसमा चाहिँ जस्तै युनिकास्ट भनेको उसको युनिक उसमा भयो जस्तै IPv4 मा जुन युनिकास्ट एड्रेस छ एउटा युनिक एड्रेस, हरेक स्टेसन हरेक होस्ट हैन हरेक डिभाइसको आफ्नै युनिक एड्रेस IP address भयो भने we call this as unicast. And multicast एउटा मल्टिपल डेस्टिनेसनमा अथवा एउटा ग्रुपलाई मल्टिकास्ट ग्रुपलाई पठाउनु पर्यो भने IPv6 पठाउनु पर्यो भने then that's known as multicast. Anycast भनेको like anycast is used by big tech companies जस्तै Google भयो Facebook भयो हैन यिनीहरुको चाहिँ के छ सर्भर्स they are located at various destinations हैन अब थुप्रो जस्तै अब गुगल हान्यो भने इट्स इन माउन्टेन भ्यू हैन त्यसपछि इट्स मेबी सिङ्गापुर हैन इन्डियामै छ अनि त्यसपछि हामीले google.com हान्छौँ नि अनि एनीकास्ट भनेको के भन्दा गुगल एनीकास्ट एड्रेस अफ गुगल इज सेम इन युएस माउन्टेन भ्यूमा भएको उनीहरूको सर्भरको र इन्डियामा भएको सर्भरको एनीकास्ट एड्रेस सेम हुन्छ तर लोकेसनले चाहिँ कस्टमा के गर्छ उले कस्टमा कम कहाँ पर्छ र नजिक कहाँ पर्छ भनेर एनालाइसिस गरेर त्यसपछि that packet is sent to the closest destination. त्यही भएर तपाईँ यहाँ तपाईँले google.com हान्नुभयो भने you get google.com.np. Okay, you go to India you get Google IN. तपाईँ युकेमा जानु तपाईँको अटोमेटिकली के खोलिन्छ त google.co.uk खोलिन्छ हैन तपाईँ युकेमा जाँदा google.com.uk खोलिन्छ नि अमेरिकामा जाँदा google.com खोलिन्छ दिस इज बिकज अफ द एनीकास्ट एड्रेस हैन सबैको एउटै हुन्छ र उसले नजिकको डेस्टिनेसन आफैले के गर्छ त डिटरमाइन गरेर प्याकेज पठाउँछ ओके सो in case of IPv6 we don't have broadcast हुँदै नहुने भन्ने त हैन but it's not used and even then like IPv6 for instead of broadcast IPv6 all node multicast address will provide the feature of broadcast. Okay. Broadcast is normally
सर स्लाइड नै
not
चेन्ज भयो
सबैको जस्तै you can provide you address
आजलाई यति गरौँ सर केही पनि बुझ्दैन पढाएको
multicast anycast slide change भएको छैन
सर
okay then we stop this for today. Okay we'll stop until this we'll again do the class. But what shall we do with the holiday ho holiday बस्नु what's way to
सर होलिडे नै गर्ने हो भोलि त
shall we take the class tomorrow? Yes sir.
No sir.
This
No sir.
you want to celebrate